The year is 2021. 7.8 billion people populate the Earth. Gigantic metropolises are the linchpin of our modern civilization. Everything is connected, and everyone has all of human knowledge in their pockets. Can you still discover something in such a world? Legendary adventures in the style of Charles Darwin or Alexander von Humboldt seem to have died out forever. But appearances are deceptive. We still know so little about our blue planet. In the few centuries since we have been doing science, we cannot possibly have read through the book that has been written for the past 4.5 billion years. There are still countless unread chapters. One of them takes place in a site that spans almost the entire planet, where there are deep canyons and gigantic mountains, and which is home to exotic creatures that no human has ever seen before, the deep sea. It has remained largely unexplored to this day. Its sheer size, extreme water pressure, and absolute darkness make exploring it an incredible challenge. For humans, the deep sea is just as hostile as space. But here, it teems with life. Some estimates assume 100 million species. The deep sea could even be the cradle of life itself. Extensive research would redefine our understanding of the big picture on Earth. And with this knowledge, we can contribute to the well-being and continuity of all life. But how can the exploration of the deep sea, which has a volume of more than 6 trillion liters, be accelerated sustainably and area-wide? This requires a completely new approach. Millions of research probes systematically distributed in the oceans are needed, which behave so passively and are so environmentally friendly that they integrate into the ecosystem like a living being itself. The highly specialized probes only have one single task. They have to take pictures in razor-sharp quality of all living beings that swim past them, while they drift with the ocean currents in the deep sea for as long as possible. Here, it is so spacious, dark, and monotonous that an encounter with an animal must inevitably happen by chance. In order to be able to finance the required number of research probes, people from all over the world can buy their own probes to leave their mark on the history of biology. Another source of revenue is the sale of image rights to media companies, for example. However, since the probes are distributed across the entire ocean from a certain number onwards, targeted recovery by ship is unecological and unaffordable. For this reason, after surfacing, they have to send their data to a server via satellite and then submerge themselves. Nature must not be disturbed in any way, which is why the top priority in any case is the entire probe must be constructed in such a way that it interacts with its surroundings no more than another stone on the sea floor. For this reason, all environmentally harmful substances must be avoided as a matter of priority. These are mainly substances such as plastics, copper, lead, silver, aggressive liquids, or other substances that could disturb the delicate balance of the sea. Instead, common elements of the Earth's crust and the seawater should be used, such as silicon, aluminum, iron, calcium, potassium, or magnesium. Elements of life such as carbon, nitrogen, hydrogen, or oxygen, and other elements that are harmless to life, such as gold, platinum, or titanium. The probe should also be built as small as possible and contain only the components that are absolutely necessary for its function in order to minimize the pure amount of material. These measures in mass production are intended to reduce production cost to a level that makes the desired business model feasible. The following basic components are required to fulfill the mission: control electronics, a 360-degree camera, a memory, a power supply, LEDs, antennas, various sensors, and of course, a spherical pressure cover. How can this technology be implemented with the mentioned requirements? First, the conventional FR4 circuit board made of plastic and copper is exchanged for a circuit board made of aluminum oxide ceramic. The so-called thick film hybrid technology is used. All integrated circuits and other components that are based on silicon semiconductors, such as microcontrollers, diodes, LEDs, transistors, or flash memories, have to be mounted to the circuit board as so-called bare chips. This means that there is no housing, which is usually made of plastic, and only the pure semiconductor chip is used. The chips can be attached to the circuit board without additional auxiliary materials, for example, by eutectic soldering at 363 degrees Celsius. A gold-silicon mixture is created between the chip and a gold surface burned into the circuit board, which is called eutectic. This ensures a stable connection. The electrical contact is then made solder-free using the gold wire bonding technique. Other typical components such as resistors, capacitors, inductances, antennas, and sensors are also implemented in an environmentally friendly form and can in some cases be burned directly into the circuit board using thick film technology. All components are electrically connected by conductor tracks made of gold particles embedded in glass. Gold tin solder can be used where soldering is mandatory, be it for electrical contacting or for joining components. In all wiring, aluminum can replace the usual copper. There is no need for plastic insulation. Instead, an aluminum oxide layer can serve as insulation, although care should be taken to ensure that the wires do not touch. The CCD chip is also applied as a bare chip. Now, what about the lens? The pressure envelope itself can also be the first lens of a 360-degree camera. The advantages are obvious. The synergy of functions allows the amount of material to be significantly reduced, while at the same time the lens diameter and thus the light collecting capacity is increased enormously, a property that is urgently needed for quality photos in dark depths. In order to realize the battery in an environmentally friendly way, 2 electrodes are attached to the outside of the sphere, and the salty seawater itself serves as an electrolyte. The cathode consists, for example, of carbon or platinized titanium, and the anode, for example, of magnesium. During the generation of electricity, the anode slowly dissolves and releases magnesium ions in the sea, which by nature are already among the most common ions in seawater. Due to the use of virtually inexhaustible electrolyte and the chemical decomposition of the anode, the battery has a very high energy density. Attaching it to the outside also creates a possibility of significantly reducing the sphere diameter. Quartz glass is used for the pressure envelope instead of acrylic glass, which is often used in underwater applications. In order to connect the 2 hemispherical shells, a vacuum is created inside the sphere. This solution has a number of advantages: the reduction of material and manufacturing costs, the prevention of condensation and oxidation inside, and the quick detection of a leak during assembly. The principle of the active motion detector is used to detect the animal. In contrast to the usual motion detectors that use light in the infrared range, blue light should be used in the deep sea, as it has the greatest range in water. All other wavelengths are absorbed exponentially. Another advantage of the blue light is that it attracts the animals according to the principle of the famous frogfish. The LEDs flash at periodic intervals for a fraction of a second. The emitted light is reflected by the animal and registered in the CCD sensor, and the photo is taken almost at the same time. The LEDs simultaneously provide the light for detection and the light for photography, while the CCD simultaneously serves as a detection sensor and light collector for the photo, an efficient synergy of functions. The information in which depth the photo was taken is very important from a biologist's point of view, but it is also essential for the logic of the onboard computer. The depth can be determined using a metallic strain gauge on the inside, which can be applied directly to the quartz glass as an extremely thin layer, using what is known as cathode sputtering. The slight compression of the outer shell as a result of the water pressure can be measured and converted into a depth. The information on which longitude and latitude the photo was taken can only be determined indirectly with an onboard clock, since no contact with the GPS can be made at depth. Therefore, with the knowledge of the starting point, the point of ascent, and the ocean currents, it is necessary to simulate where the probe was at the time of the photo. This allows the animal's habitat to be narrowed down. The probes are brought into the sea at regular intervals along the route of a ship. A ship does not necessarily have to cross the ocean just for this task. Freight and passenger ships, which do this anyway, could also be included in order to not generate additional CO2 emissions and to reduce costs. The probe sinks slowly into the depth. Its journey of discovery is already beginning. It has a power supply and it is operational. During its time in the sea, the probe will drift away with the ocean currents and can thus explore larger areas without the need of its own drive. After a certain time, it reaches the sea floor at an average depth of 4,000 meters. Here, it will linger until the chemical decomposition of the anode has progressed so far that the buoyancy slowly but surely gains the upper hand. And while floating upwards, it happens. An unknown species of epic proportions triggers the camera trap. After its excursion into eternal darkness, the probe reaches daylight again and immediately starts sending the valuable data. Once its work is done, the probe continues to float on the surface until the anode has dissolved so much that the connection to the inside of the sphere is leaky. Water penetrates and causes the probe to sink. The remains are gradually covered with sediment on the ocean floor. We don't know what to expect on this trip. Maybe we will even find the largest animal on Earth down there. Everything is possible. We can let our curiosity run wild. And maybe one day, the technology could also be used on the icy moons of the outer solar system to search for extraterrestrial life forms. Revolutionize biology and become part of this great adventure.